Good morning. Real number system is a broad topic in core mathematics. Most examination bodies set most of their questions from this very topic. The West African Senior Secondary School Examination Council is a no exception of this. Now, the calculator is very powerful in such a way that it can solve most of these questions during the examination. In the objectives, most questions appears under real number system because it's a very broad topic in year one. Now, apart from these questions appearing in the objectives, you can also be asked in the session B. Most of these sub-questions are approximations, where after your calculation in the session B, you'll be asked to approximate your answer into a particular number of decimal places, into a particular number of significant figures, into a nearest number, and many others. So, with our literate knowledge about the use of the calculator, it makes our A1 in the mathematics exams room very easy. Just subscribe to our channel for all the tutorials. Now, let's look at, or let's visit our tutorial to solve past questions under real number system. As we used to know, our materials for all our tutorials are the calculator. So you make your calculator ready, your notepad for taking your own personal notes, and we'll be using the calculator tutorial guide by Frankie Opon. We always say that if you want a copy of this guide, this is the book. So if you want a copy of this guide, you just contact the number that is below the screen. The number below the screen, and you surely get a copy. Okay. Now, so this is chapter 3 in the book, but we want to begin that one first because it has all other topics based on real number system. All other topics based on real number system. So, we want to begin with real number system tutorials. In the mathematics class, can you vividly recall rational and irrational numbers? We got to know that rational number is any number that can be expressed as a quotient, that is a fraction of two integers. If R is a rational number, then there are two integers, A and B, such that R is equal to A over B. Rational numbers are recognized to be fractions. The numbers 8, 9, 45, 8, 7, 6 are all examples of rational numbers. In chapter 1 of this book, we became familiar with some calculator keys such as the fractional key. This key is used to enter fractions, the bracket rational numbers on the calculator. You can also recall irrational numbers, as we used to know, is a number that cannot be expressed of the form A over B. Irrational numbers are non-recurring, non-terminating. Examples: the root of all prime numbers, the values of pi, etc. are all examples of irrational numbers. Let us go through the step-by-step approach in solving the following past questions with the calculator. Calculator tutorials. Now, so for the content of this calculator tutorial book, it introduces us to the topic and we tackle the subtopics with our calculator. You may have already noticed that many fractions, when represented as decimal, need the full calculator display to represent them. This is usually because they are recurring or repeating decimal that have an infinite and never-ending representation as decimal. Here are two examples. Now, let's go to our screen. When we plot the fraction, 1 over 3. 1 over 3. Now we press the equal to sign. If you can recall, in our previous tutorials, when we get a fraction like this, to represent it in decimals, we want to know whether this fraction is a recurring decimal or a non-recurring decimal. We want to know if this is a rational number or a non-rational number. So we press equal to, we press SD. SD. Now, what is happening? What you are seeing right now means that the 3 is recurring. The 3 is recurring. So anytime you see this, you should know that this is what? A recurring what? Decimal. So 1 over 3 is a recurring decimal. So you can see that calculators and computers always have a finite amount of space to represent numbers. So cannot represent infinite decimal completely. In these two cases, it is fairly easy to see the repeating pattern involved and to see how they will continue. So you can see this version of the calculator let us know that this is a recurring what? Decimal. In most books, you may see a representation of recurring numbers with a bar. With a bar on the 3. Demonstrating that it is what? A recurring number. Good. Let us also move to 14 over 99. So in an objective, you can be asked this question. If it is a recurring or non-recurring, we should really know that exactly from the calculator that it is a recurring decimal. Let us move to 14 over 99. 14 over 99. We press equal to convert it to decimal, we press SD. Now, look at what is happening. 0.14, the 14 is in brackets. In other way, you can also get a bar on the 14. It means that the 14 is repeating itself. It is repeating itself to infinity. So you can see this is also what? A recurring decimal. Very good. You can try this 2 over 7, 2 over 17 on your calculator to determine whether they are recurring or not recurring. The first of this is easier to interpret than the second one, as the display has some repeating digits, 2857, which suggests that the decimal representation 2 over 7 is equal to this. It tells you the repeating pattern of this particular what? Rational number. So you can be trying this for yourself. You can be trying some examples for yourself to know. Good. Let us solve a past question. Is it that which of this is or are rational? Which of this is or are rational? Now, in the beginning of this tutorial, we learned that rational numbers are numbers that can be represented in the form of what? Fraction. That can be represented in the form of what? Fraction. Very good. And also, rational numbers can be recognized as fractions. And examples, we stated some examples. Also, irrational numbers, we are saying that they are numbers that cannot be expressed in the form of what? Fraction. And they are non-recurring, non-terminating. They never recur and they never what? Terminate. Very good. Now, let's go to our past question, 1993. Question number 48. So which of the following is a rational number? They are all sets. It means that every content of the set should meet the requirement in order to qualify it to be what? A rational. Good. So, to consider the options here, that is I, and I. First, considering I, you want to determine whether it is a rational number. So, you determine all the content of the set P. 2. 2 is a rational number because it can be expressed in the form of what? A fraction. For example, 4 over 2 is 2. 8 over 4 is 2. They are all giving us, or they are all rational numbers. Good. Now, root 3. Root 3, when we put root 3 on our calculator, root 3, and we press equal to, press SD to know the decimal corresponding values. Very good. Now, all you are seeing here is irrational number. It is moving to infinity. It is not terminating. It never terminates. Now, do you know what is happening? We say that the root of every prime number is an irrational number. So, immediately you see a prime number inside a root sign, you know that that number is what? Irrational. And we have been asking the question that which of the following is a rational number? So, the whole of this I, the set A, the root 3 disqualify it to be a rational number. Good. Let's go to II. That is set Q. 7 is a rational number. It can be expressed in the form of fraction. 14 over 2, 7 over 1. They are all rational numbers representative of 7. 1 over 6 is a rational number. Root 9. Root 9, when we punch root 9, you get what? 3. 3 is what? A rational number. So in fact, the set Q, that is II, is a rational set. A set of what? Rational numbers. When we go to III, we are talking about a range of numbers from -3 towards negative, to +8. So all the numbers that can be found between -3 and 8. When we see a representation like this, never think of only the whole numbers. You should also know that there are some decimals in between them. Even from -3 to -4, they are -3.1, -3.12, -3.1234567. So you can see that in between them, there are some irrational numbers in between. They are irrational numbers. They are numbers that will continue unterminated. It makes it irrational. So only the III here is what? A rational number. Let's look at the demonstration. So 7 and 1 over 6 are rational numbers, and with 9 result 3, which is also rational. In fact, the book explains every question. For every past question, it explains it. Why the answer is this. It gives an explanatory note about why the answer is a particular option. So root 3 disqualifies the set P to be rational since the square root of any prime number is an irrational number. When you confirm on the calculator, you punch, you get 1.732048. In fact, it continues, which is non-recurring and non-what? Terminating. It is never recurring. There is no number that is recurring, repeating pattern. And it is never terminating too. It never stops. That is what we refer to as an irrational number. Very good. Now, we want to move to the next fractions. We have already have a tutorial on fractions. Fractions and mixed fractions, how to represent them on a calculator in our previous tutorial. So, proper fraction, improper fraction, mixed fraction. Now, we should all know how to enter all these fractions on our calculator. If you are new to this video, then you go back to the channel to subscribe to get all the tutorials that you missed. Good. We want to solve this past question. SSE 1996, question 3. Most of our questions, simple question like this, then you will be worrying yourself coming to convert it, dividing it by 1,000, and wasting your time in examination hall. While with a single click, you get your answer. Express 0.315 as a fraction in its lowest term. This is an objective question, so why waste time on it? Let's demonstrate. We want to express this. We are converting it from this decimal representative to what? A fraction of its lowest form. So we go to the fraction, so we punch what we see here on the calculator, that is 0.315. 315. Then we press equal to. When we press equal to, it will give you the fraction representative of that particular decimal in the simplest way. So the steps, so we punch the exact, so the book will give you the steps. In fact, when you get one of the books, you know that you are approaching your A1 in mathematics. So 0.315 decimal value to be converted to fraction on the calculator, we punch it exactly. We press the equal to as we did. Then the answer is 63/200. So when you get your past question book and you look at it, you see that the answer is 63/200. Let's go to SSC November 2001, question 9. We have to also express 0.415 as a fraction in its lowest term. So we go. We first enter the decimal in the question. 0.415. Then we press equal to. So we follow the steps in the previous question above. So you see, we are getting 83/200. Most of the past questions are in this simple question. Express 0. So you can try this question yourself on your calculator. 0.275. You press equal to. It will give you the answer in the simplest form, the simplest fractional form. Very good. So it will give you the answer in the simplest form. So that is the simple way to convert decimals to fractions in the simplest form. Instead of going through stress of dividing by the number of digits that comes after the decimal places, divided by 1,000, dividing by 10,000, and doing cancellation to waste your time. There is a single click to secure your mark. Remember, in the examination room, a single mark will let you get F9 or A1. So never pray with a single mark in the examination room. So that is it. That is the introduction. So we have representation of percentages. So you will be converting fraction to percentages. Percentage to fractions as we treated or we learned in year 1 during real number system. So with our next video, we'll be tackling with this, representation of percentage, converting fractions as percentages as fractions, and others. So you don't have to miss our subsequent videos. We'll be dealing with operation on rational numbers. In fact, you'll be tackling board mass. We learned how to solve mixed fractions, entry of mixed fractions on our calculator. You'll be solving questions on board mathematics in our next video. Thank you for following us for today. What we always say is that when you get the video, you share with your friends and you subscribe. You subscribe so that anytime a new video is released, we prompt you or give you a notification. That is what you always say. A sharp brain publication helping to minimize or reduce drastically fails in mathematics and help students achieve their aim in life. Don't forget to subscribe to our YouTube channel.